Okay, so you're getting ready for a senior software engineer technical interview, right? And while you're deep in all those algorithms and system design concepts,
Yeah.
we're going to shift gears a bit. We're going to kind of sharpen your understanding of some really fundamental programming concepts, that kind that tend to pop up in these interview discussions. It's all about reinforcing that core bedrock of your knowledge.
Yeah, absolutely. It's like going back to basics, but with a senior level lens. We're talking functional decomposition with static methods, how to work with arrays effectively, and that really cool flexibility you get with variable arguments.
And it's not just about knowing the syntax. It's about proving you can use these fundamentals to write code that's, cleaner, more modular, more adaptable in the long run.
Mm.
And those are the hallmarks of a great senior engineer.
Exactly.
Okay, so let's start with functional decomposition using those static methods. Let's say you're looking at this massive main method, like hundreds of lines long. What's the first thing that screams problem to you, and what's the whole idea behind breaking that down?
Well, the biggest issue with the really long method is that it's just too complex. It becomes super hard to read, to understand, to debug, let alone maintain it. Functional decomposition is all about tackling that complexity head on. You break that monster task into smaller, well-defined subtasks, and each of those gets its own little method.
Right, so it's kind of like organizing your code into logical units.
Yeah.
And for those simpler utilities within a class, static methods come into play.
Mm-hmm.
So what exactly is a static method, and how does that help us organize code better in this context?
A static method, you can think of it as a utility function that's tied to the class itself, not to any specific object of that class. You declare it with that static keyword. The beauty of it is you can call a static method directly using the class name. No need to create an object first. This makes it super useful for those self-contained operations that don't mess with any internal object data. So when you have this ridiculously long method, you can spot blocks of code doing specific things, pull them out into separate static methods with descriptive names, and boom, your code suddenly becomes way more readable and understandable. And if a bug pops up, you can often zero in on the problem area so much faster because of that modularity.
Yeah, makes total sense. So when we're actually declaring this static method, what's the basic structure we're looking at?
It's pretty straightforward. You'll usually have what we call the method's access modifier, like public, which means anyone can use it. Then comes that static keyword we talked about, followed by what the method returns. This could be like an int, a double, a boolean, or even void if it doesn't return anything. Then comes the name of the method, make it meaningful. And lastly, in parentheses, you've got the parameters it takes with the type and name for each. This whole shebang is what we call the method's signature or header. After that, you've got the method body, which is the actual code doing the work, enclosed in curly braces. And if you're returning something, you'll have a return statement in there to send that value back.
Right. Can we break down a real example? Let's say public static double average, double X, double Y. Walk me through what each piece means here.
Sure. So public, like we said, means anyone can use this method. Static means it belongs to the class itself. Double tells us that this method is going to spit back a number, a decimal number to be precise. Average is just the name we gave it. And finally, you've got double X, double Y, which tells us it takes in two decimal numbers as input. We've called them X and Y. And inside the method's code block, you'd expect to see the calculation for the average of those two numbers, and then that return statement giving you back the result.
Let's say I want to use this average method from, say, my main method all within the same class. How would I actually call it?
You just call it like this, average AB, where A and B or whatever decimal numbers you want to average. And since it's a static method in the same class, you don't even need to mention the class name here. Then whatever average spits back, you can store that in another variable if you want. Something like double result is doses average AB.
Got it. Now, a quick one. Does it matter where I put this static method in the code file compared to the main method? Like, does it need to be before or after?
No, not really. I mean, as far as the Java compiler is concerned, the order within the same class doesn't really change how it understands or runs your code. But for us humans, to make it easier to read and maintain, a lot of developers follow certain conventions. Like you might group related methods together or try to keep things flowing from top to bottom, just for readability.
So bringing it back to those senior level interviews,
Yeah.
how does this whole functional decomposition thing using static methods actually come up? What kind of scenarios or questions should I be prepared for?
Imagine they throw a chunk of code at you, really messy and complex, and ask, how would you clean this up? That's your cue. You jump in and talk about breaking it down, functional decomposition style. Extract those logical chunks into nice, neat, static methods. Explain how that makes the code easier to read, easier to maintain, easier to test. They want to see if you're thinking about good code organization, something that's super important when you're leading development on big projects. And they might even ask you point blank, why is modularity so important? And that's where you hit them with the benefits. Like debugging becomes a breeze because you can isolate problems faster. You can reuse those static methods if they do general tasks. And overall, the entire code base becomes much easier to understand, especially for new folks joining the team. It's night and day trying to debug one giant 500-line method versus tracing an issue through a bunch of well-named 20-line methods. The mental load is just way less.
Right. That makes sense. So let's move on to arrays. One of the key things is how we pass arrays to methods. What's the one thing I absolutely need to remember about this?
The big thing to remember is that in a lot of languages, including Java, arrays are passed by reference. This means when you pass an array to a method, what the method actually gets isn't a copy of the whole array, but more like a pointer, a reference to where that original array lives in memory. So the big consequence is that if the method changes the array using this reference, it's actually messing with the original array in the calling code.
We've got a classic example of this with a method called swap paint values in I in j. Can you walk us through how that method actually works?
Sure. So swap. It takes an array of integers called values, and then two more integers, I and j. The goal is to switch the elements at those positions I and j within the array. And to do this, you usually need a temporary variable. So first, you grab the value at position I in the values array and stick it in that temporary variable. Then you take the value at position j and copy it over to position I, overwriting what was there. Finally, you take the value you saved in the temporary variable, which was originally at position I, and put that in position j. And because the method's working directly with a reference to the original values array, these swaps actually change the original array.
So if I call this swap method with an array in two positions, after the method's done, the array I gave it will actually have those two elements swapped.
Exactly. The swap method's changes stick around, and they're reflected in the original array even after the method call is over.
Now, what about methods that return arrays as their result? Does it work the same way?
Not quite. Usually when a method returns an array, it's creating a brand new array in memory and then giving you back a reference to that new array. So unless the method is specifically designed to modify the array it got as input, like our swap example, the original array stays untouched. The caller just gets a reference to this fresh new array, and they can play with it however they want without affecting the original.
We've got an example called firstLastIntValues. What does this method do, and what's important to understand about how it affects the input array?
So the firstLast method takes in an array of integers called values. Now, a good implementation of this would start by checking if that input array is empty. If it is, it'll probably just return a new empty array, just to handle that edge case gracefully. But if it's not empty, the method will create a brand new array, usually with space for just two elements. The first element of this new array will be filled with the first element of the original values array, the one at index 0, and the second element will be filled with the last element of the original array. Finally, the method returns a reference to this newly created two-element array. The important thing to remember is that the original values array remains completely unchanged. The firstLast method is just peeking at its contents to build a completely separate array, and it returns that new one.
So knowing when you're modifying the original array versus creating a new one seems pretty crucial to avoid surprises in your code.
Yeah.
How might interviewers dig into whether I really get this?
They might give you snippets of code and ask you to predict what the output would be, especially focusing on whether a method call is going to mess with the original array or not. So understanding how arrays are passed by reference is key here. They could also ask about situations where it makes more sense to change an existing array versus making a new one. And that often comes down to things like how efficient your code is, because creating new objects all the time can slow things down, how much memory you're using, and whether you need to keep that original array intact. Like if you're writing an algorithm that sorts an array, you might choose to sort it in place to avoid making a copy, especially if it's a giant array. But if you need to process an array and still need the original version later, returning a new array with the results would be the way to go.
Right. Gotcha. So let's wrap things up with our last concept here. The whole idea of variable arguments, or as the cool kids call them, Varargs. We've all seen this funky dot syntax in methods like print. What's the basic idea behind it?
Varargs, they basically give you a neat way to define methods that can handle a bunch of arguments, and you don't even know how many you'll get beforehand, but they all have to be the same type. It's like saying, hey, you can throw as many numbers at me as you want, and I'll deal with it. The print example you mentioned is perfect. It takes this format string and then a whole bunch of arguments that go into the placeholders in that string. You never know how many arguments you'll need until you see the format.
Okay, let's take a closer look at this with an example, let's say. Public static, double average, double dot values. Break down that double values part for me. What's going on there?
So that double values in the declaration, that's the magic of Varargs. It tells the compiler, hey, this average method can handle 0 or more decimal numbers as input. What happens behind the scenes is when you call this method, like with average 3.0, 4.5, -5.0, 0.0, Java takes all those individual numbers and packs them neatly into an array of doubles called values. So inside the average method, it's like you're working with a regular array named values.
So the implementation of this average method would then just loop through this values array, add up all the numbers, and calculate the average, right? Just like if it had gotten a regular array in the first place.
Yep, exactly. You'd start with a sum variable, set it to 0, and then you use a loop, maybe a nice for each loop, to go through each number in the values array, adding them to the sum as you go. Finally, you divide that sum by the number of elements in the values array, which you can get with values.length. And of course, a good implementation would check if the array is empty to avoid that pesky division by 0. Maybe return 0 in that case.
And what if I already have my data in an array to begin with? Can I still pass that to a method that uses Varargs?
Oh, absolutely. If you've got a double array, let's call it scores, you can just pass it straight to the average method like this.
Yeah.
Average scores. Vargs are designed to handle both individual arguments and whole arrays, so you're good to go either way.
Are there any rules I should keep in mind when using Varargs in my own code? Any gotchas?
Yeah, there's one big one. That Varargs parameter must be the last parameter in the method's list. So you can have other regular parameters before the Varargs, but not after. This is so the compiler can tell which arguments belong to the Varargs and which belong to the regular parameters.
Right, like in this example, max, double first, double dot rest. Explain what that's doing.
So in this max method, that first argument first has to be a decimal number, meaning when you call this method, you have to give it at least one number right off the bat. Then you have that double rest, which is our Varargs parameter, and it says, hey, you can give me 0 or more additional numbers after that first one. A typical way to implement max is to start with a variable, maybe call it result, and set it to that first argument. Then you go through each number in the rest array, and if you find a number that's bigger than your current result, you update result. That way, you end up with the biggest number among all the ones you were given, starting with that initial first number as the baseline.
So when would you, as a seasoned senior engineer, think about using Varargs in your own code? What are the design considerations there?
Varargs are really handy when you're writing methods that need to handle a flexible number of inputs, and where treating those inputs as a collection makes sense. Think of methods that calculate stuff like sums, averages, find minimums or maximums, or even build strings from a bunch of pieces. Varargs can make your code a lot cleaner and easier to use, since the caller doesn't always have to create an array manually. But you gotta be careful too. If a method is always supposed to get a fixed number of arguments, it's usually better to just define it with those specific parameters. Using Varargs everywhere can sometimes make your code harder to understand because it's not clear what inputs are expected. The key is to use them strategically when they actually make your methods more flexible and easier to use.
This has been a really great deep dive into these foundational programming concepts. Just to recap, we've talked about how functional decomposition, using those static methods, helps us organize complex code, the key differences between how arrays are passed into and returned from methods, and that cool flexibility that variable arguments give us for methods that need to handle a bunch of inputs.
Absolutely. And as you get ready for those senior level interviews, just remember having a solid grasp of these core concepts is really crucial. It shows that you don't just write code, but you can design and structure it well, which is a big deal for a senior engineer.
So as you continue prepping, here's a little something to think about. Think about these core building blocks: functional decomposition, how you manipulate arrays, and those variable arguments. How could you use these seemingly simple ideas to design and maintain really robust and scalable systems at a senior level? Think about how these concepts play out in real-world problems and how you can anticipate future needs. Mastering these fundamentals really sets you up to tackle the more advanced challenges that come your way. Thanks for joining us for this deep dive.